Trigonometric functions, angles, SOH CAH TOA. What are they? Trigonometric functions are functions related to their angle, including sine, cosine, and tangent, and their reciprocals, cosecant, secant, and cotangent. Why? Used in several imaging software, including CAT and MRI scans. Interesting fact: skeletons of now extinct species of sloth suggest some varieties used to be as large as elephants. Now, let's take a look at the definitions. The first set are the stars of the show. We have sine, cosine, and tangent, where sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Next we have the reciprocals, cosecant, secant, and cotangent. One way to remember is the mnemonic SOH CAH TOA, where S stands for sine, O for opposite, H for hypotenuse, C for cosine, A for adjacent, H for hypotenuse, T for tangent, O for opposite, and A for adjacent. Now let's take a look at the reciprocal identities, where we have sine of beta is equal to 1 over cosecant of beta, and we can switch sine and cosecant since they are reciprocals. Next we have cosine of beta is equal to 1 over secant of beta, and we can switch cosine and secant since they are reciprocals. Next we have tangent of beta is equal to 1 over cotangent of beta, and we can switch tangent and cotangent since they are reciprocals. Finally, we have tangent of beta is equal to sine of beta over cosine of beta, and cotangent of beta is equal to cosine of beta over sine of beta. Now that we have all those definitions and identities in our head, let's take a look at the examples we're going to discuss in today's video. Let's take a closer look at example 1. Let's read the steps. Step 1, draw. Step 2, find angle indicated. Step 3, use SOH CAH TOA. Now, let's read the question. Find the values of the 6 trigonometric functions for the angle theta. Let's write down the stars of the show: sine, cosine, and tangent. Using SOH CAH TOA, we know sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent, or sine over cosine. Now, let's take a look at the triangle. We have a right triangle, where 3 and 4 are the legs, and 5 is the hypotenuse. Now, let's use theta to orientate ourselves. So which one is the opposite leg, the adjacent leg, and the hypotenuse? Well, that all depends on where theta is. In this case, theta is the top left angle, so the orange side length is opposite theta, the blue side length is adjacent theta, and the green side length is the hypotenuse. Now we know which one is which. Let's start with sine, and substitute 3 for opposite, and 5 for hypotenuse. Let's continue with sine, and substitute 4 for adjacent, and 5 for hypotenuse. And finally tangent. What do you think tangent is equal to? That's right, 3 for opposite and 4 for adjacent. Now let's move on to the reciprocals. Remember, the reciprocals are flipping the fraction, so 3 over 5 becomes 5 over 3 for cosecant, and 4 over 5 becomes 5 over 4 for secant, and 3 over 4 becomes 4 over 3 for cotangent, and that is example 1. Before we move on to example 2, let's take a look at a special triangle. Here we have an equilateral triangle, with 2 for each side length. Now let's draw a perpendicular bisector that cuts the angle and the side length in half. We just created another special triangle. Well, 2 of them, and they are called a 30, 60, 90 triangle, because those are the angles. Now let's find the perpendicular bisector using the Pythagorean theorem, and the measure is square root of 3. Let's use the 30-degree angle as theta. So let's bring back the stars of the show. So we have sine of 30 degrees, cosine of 30 degrees, and tangent of 30 degrees. So sine of 30 degrees is opposite over hypotenuse, or 1/2. And cosine of 30 degrees is adjacent over hypotenuse, or square root of 3 over 2. And tangent of 30 degrees is opposite over adjacent, or 1 over square root of 3, which becomes square root of 3 over 3. Now, what if we use the 60-degree angle as theta? Let's find out. So let's bring back the stars of the show once more. So we have sine of 60 degrees, cosine of 60 degrees, and tangent of 60 degrees. So sine of 60 degrees is opposite over hypotenuse, or square root of 3 over 2. And cosine of 60 degrees is adjacent over hypotenuse, or 1/2. And tangent of 60 degrees is opposite over adjacent, or square root of 3 over 1, which becomes square root of 3. And that's how we use SOH CAH TOA with any equilateral triangle. Let's look at another special triangle. Here we have an isosceles right triangle, and we can call it a 45-45-90 triangle because those are the angles. Let's use the Pythagorean theorem to find the hypotenuse, and the measure is square root of 2. Let's use the 45-degree angle as theta. Which one? They're both the same, so it doesn't matter which one we choose. So let's bring back the stars of the show. So we have sine of 45 degrees, cosine of 45 degrees, and tangent of 45 degrees. So sine of 45 degrees is opposite over hypotenuse, or 1 over square root of 2, which becomes square root of 2 over 2. And cosine of 45 degrees is adjacent over hypotenuse, or 1 over square root of 2, which becomes square root of 2 over 2. And tangent of 45 degrees is opposite over adjacent, or 1 over 1, which becomes 1. And that's how we use SOH CAH TOA with any isosceles right triangle. Now let's move on to example 2. Let's read the question. Find the exact values of m and n. Let's read the steps again. Step 1, draw. Step 2, find angle indicated. Step 3, use SOH CAH TOA. First things first, let's label our missing angle. It is 30 degrees. So we have a 30, 60, 90 triangle. Let's use the 60-degree angle as theta. So let's bring back the stars of the show. So we have sine of 60 degrees, cosine of 60 degrees, and tangent of 60 degrees. Using SOH CAH TOA, we have opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. Now let's substitute the variables from the triangle into what we have so far. So sine of 60 degrees becomes m over n, and cosine of 60 degrees becomes 5 over n, and tangent of 60 degrees becomes m over 5. Now let's give sine of 60 degrees, because it has two variables. Let's begin with cosine of 60 degrees. Using the properties of a 30, 60, 90 triangle, we know cosine of 60 degrees is equal to 1/2. So we can set 1/2 is equal to 5 over n. Let's cross multiply, so n is equal to 10. Let's continue with tangent of 60 degrees. Using the properties of a 30, 60, 90 triangle, we know tangent of 60 degrees is equal to the square root of 3, or the square root of 3 over 1. So we can set the square root of 3 over 1 equal to m over 5. Let's cross multiply, so m is equal to 5 square root of 3. And that is example 2. Before we move on, let's continue with sine of 60 degrees. Let's substitute 5 square root of 3 for m and 10 for n. Let's simplify, so sine of 60 degrees is equal to the square root of 3 over 2. Now it is your turn, so go ahead and pause the video here so you can take your time to answer this question, and I'll show you the results in 3, 2, and 1. Did you get it correct? Superb. If not, there's always tomorrow.